Hello class, in this video we're going to continue our discussion in news vendor problem. Instead of having only one source of randomness, which is the demand in a regular price is following a triangle distribution, now we have two additional sources of randomness. First is the supply source. So for example, you order 200 units, but the maximum amount the supplier can give to you is following this distribution. And the second source of randomness is this secondary market. You can sell the leftover product with a price of $10, but the demand for those leftover is following a normal distribution. So let's do this. The first, we're going to define our first the uncertain supply. So we're going to define distribution. As you describe here, the maximum supply is following a discrete distribution. So we're going to choose discrete distribution. It has two set of parameters. First is the value they can take for those distribution. So it's from D15 to D19. And the second set of parameter is the chance of taking these values from E15 to E19. As you see here, the risk would ultimately give you a preview for the distribution function is a discrete distribution. Let's press OK. And the actual supply is the maximum of, it's just the minimum of your order quantity and the amounts your suppliers can give to you. Oh, by the way, let's change the setting to random value so that every time you update your formula, you would generate another random value for you. So now every time you hit F line, you can see different realization of your supplies. So in this case, you order 200 units, but the supplier can only deliver 150, so your actual supply is 150. The cost then is your unit cost multiplied by the supplies. The regular demand is still following a triangular distribution, so we're going to add a triangular distribution. It has three parameters. The minimum, which in this case is described here, E4, E5, and E6. This is the three parameter of the demand and the regular selling price. Press OK, and you can add a round function to get integer. The revenue we get from this is the selling price multiplied by the amount you can sell, which is the minimum of your demand and your supply. The leftover is just your order quantity minus your demand. Oh, it's not the order quantity, it should be your actual supply, because you could not always get the order quantity you ordered. So it's the actual supply minus the demand, and we only get the positive value. So that's the amount of leftover. And for the cleanest market, it's following the demand in the for the cleanest price is following a normal distribution. So we're going to insert a normal distribution here. So the mean of this normal distribution is E line, and the standard deviation is E10. And we're also going to use the round function to get integer. And the revenue from this is the selling price, and the selling price multiplied by the amount you can sell, which is the minimum of your leftover and the demand for the secondary market. So the total profit is just your revenue under the sale plus your revenue under cleanliness minus your cost. And so the next step is to track this profit as our output. So we add output, name as profit. And to evaluate, these are the order quantity we want to evaluate. So we're going to change this to risk semi-table and make this as our alternative order quantity. And since we have 5 different order quantities, so we're going to change the simulation number to 5. And we're going to use 100 iteration each simulation, and you should actually use at least over 1000 to get a robust result. And we can click, but for the sake of time, we're going to use 100. You you can then click Start Simulation and to see the result. There's some chance that my computer may freeze when I run in this model. So if I couldn't show you the result, what you can do is after you finish this, you can click here to see the simulation for different simulation numbers, which correspond to different order quantity. Okay. Oh, actually, I could see the result. Great. Oh, it seems still running. And after this result down, you can look at the Toronto graph as we discussed in the class. This to see the Toronto result, you should be able to see which component of random list would have largest impact to our profit, because we have 3 components of random list: the demand for the regular price, and demand for the cleanest under the cleaning price, and the random list in the supply source. So you can, by looking at that Toronto graph, you will be able to tell which component of random list have largest impact on your profit. It seems this a risk is not working in my desktop. I hope this doesn't happen in the lab. So if you're done with the simulation, you can click Excel report and look at the quick report and the output summary, just to look at the expected profit under different order quantity. And so you can choose the optimal order quantity to maximize your expected profit.